So welcome, good afternoon. My name is James Serra. This topic is building an effective data warehouse architecture. This presentation came about because many, many years ago when I was DBA, my background started as a database developer. Then I got into being a DBA. I was a DBA for about 12 years. And somewhere along the line, I had a boss come up to me and say, hey, I've been reading this thing about data warehouse. At the time, I knew very little about data warehousing, and he said, this seems like a really good idea. I think we should do this for our company. Why don't you go and build us a data warehouse? And I said, no. I got too much on my plate as a DBA. I don't want to build a data warehouse. And he said, no, you're going to do it. So, all right. So immediately, I was struck with fear. They want me to build a data warehouse, and I really had no idea what a data warehouse is. I started looking and reading about dimensional and normalized data and Kimball methodology, Inmon methodology, data warehouse, data mart. It was all really confusing to me. And now I think back of the difficulty I had back then, and that's where this presentation came in, to try to educate, in particular DBAs, about what exactly a data warehouse is and what's the best methodology to use, what's the hardware you want to use. And so you can go and you can build a very successful data warehouse, and your boss will be real happy and give you a nice raise, and you can come and send me an email and say, thank you, James, for enlightening me. So during this talk, I'll ask questions, and I appreciate if you could raise your hand to help me understand and better gauge where I'm going to go with the presentation based on what skill sets we have in the room. So first one I'll ask is, how many people here are DBAs? Most people are DBAs. How many would say they are business intelligence or data warehouse architects or developers? Ooh, a lot. How many think they know data warehousing really well and want to come up here and teach it? All right. So this is good. This is good. So some of the stuff I may skip over or tread over quickly because of that. Silence. I don't know why we keep telling you the people this. It's like airlines keep telling you not to smoke on the plane. I mean, don't we know already that we don't need to smoke? Do we really need to be explained how a seatbelt works? There's a lot of past events here. How many people here are first timers at the past event? Oh my goodness, a lot. Wow. Well, this is not the only past event. There's a lot of other ones. In particular, the one in the middle, the past VA conference I spoke out last. It was the first time event earlier this year in Chicago, and they're going to have it next year in San Jose in May. And it's similar to this, except you take out all the DBA intensive stuff and you add more BI stuff and data warehousing stuff. So it's really great for BI focused and analytical focus on there. And there's a lot more managers and decision makers and business power users who go to that conference. So I wanted to point that out. Please, afterwards, if you can take a minute and fill out evaluation. It's actually, all the speakers will read these, and it helps them with any kind of comments on how we can present better. If you fill it out, it just takes a minute. I mean, if you want to go in there and go, you suck, that's fine. Just tell me why I suck so I can make my presentation better next time. So about me, this is just the fluff page, I call it, but I just want to point out, I've been doing this for a long time, and so I've been on a number of data warehouse and business intelligence projects, and so I try to interject a lot of my experiences in here. I may tell some really amazing stories or stories that you're bored about, but maybe if you're dozing off and, oh, a story, and it'll get you more interested in there. But a lot of the problems and experiences I see over and over again are very common, and they're very correctable, and so I try to point a lot of those out in our presentation. So the agenda that we're going to cover is, I'm going to talk a bit about what a data warehouse is not and what exactly is a data warehouse and why we use one. I'll jump into some of the fast-track data warehouse architecture and appliances to talk about the hardware part of it for data warehouse solutions. Define what a data warehouse and data mart is. There's a lot of confusion about the two. The meat of it will be a lot of this Kimball and Inmon methodologies. That's That's usually the part that we have the most controversy over, I should say. And then we'll get into populating the data warehouse, ELT versus ETL, and then, time permitting, we'll talk about the circuit keys, SSAS cubes, tabular model, how that changes things a bit, and some of the Microsoft BI tools. And feel free to ask questions in here. So I knew somebody was going to come with Data Vault. Damn, I can't get away from that. So Data Vault is another methodology besides Kimball and Inmon that is starting to see some traction in there. I actually went to the lightning talk for 10 minutes and talked about it. When we get to that part, you may hear me touch on it like that. So any other questions along the way, just feel free to raise your hand and we'll answer them. We don't have to wait till the very end. So what a data warehouse is not. So some of people here will be familiar with this. The first one is, I went to a client once and I said, do you have a data warehouse? And they said, oh yeah, we got a data warehouse. I was like, great. So I went and looked at the data warehouse and I said, this looks a lot like a copy of the source system that you have. And he goes, well yeah, but we preference it with DW, so it's a data warehouse. And I said, yeah, that's not really a data warehouse like that. So there's some people that get in their head what a data warehouse is, and it's important to clarify, especially if you're at a company and you're tasked to build one, to understand exactly what a data warehouse is. It's not a copy of the multiple tables from various source systems. So what winds up happening is we have a bunch of ERP systems, CRM systems, and they want to combine it all. And so one of the things they'll do is, well, we have customers know these systems, so we'll copy the customer tables over, and we'll create a view that joins them all together, and we got a data warehouse. No, that's not really a data warehouse. And the other thing that I see even more common is a data warehouse becomes a dumping ground for various tables. So a user comes to you and says, I want to create a report, and I want to combine data from multiple systems. And you go, okay, I'll do something quick and dirty. I'll copy some of these tables over from this ERP and from the CRM and from financial data, and I'll put it all in this data warehouse because it's got DW on it, and we'll create a report off that. And you think it's a temporary thing, but then it eventually grows. You give out that, the user goes and creates a report off that. He really likes it. He goes, oh, can you add a couple more tables? Can you do this system and put it in there? And another user comes in and wants something similar, and all of a sudden, this quick solution becomes a just giant dumping ground of all these tables, and it becomes a big mess. And I've gone on a lot of projects where you spend months and months cleaning up this data warehouse, or as your DBA maintaining it, and that's not a lot of fun. So this is a graph I recently saw by Wayne Eckerson on the maturity model of companies. And to quickly cover it, is most companies, you start out with the prenatal stage here, where you just got an ERP system and you're generating reports out of that system there. If you want some customization, you got to go to IT. They got to go and they got to customize a report on there, and it's very inflexible. It's only one source system, and what winds up happening is IT gets backed up with all these requests, and they can't fill them enough for the business users. So the business users say, you know what, IT, I'm going to do it on my own. I'm going to go create an Excel spreadsheet out of this data. I'm going to go into the source system. I'm going to run a report. I'm going to export it out to Excel. I'm going to do that in another system. I'm going to mash them together, and I'm going to have my report. Okay? Well, that solution starts spreading like weeds, and you have all these different departments all creating their own spreadsheets. They get passed around. I've been at clients that have hundreds of these spreadsheets all over the place, all pointing, underlying queries pointing to various source systems. And man, if you go and change a source, a database name, or you got to get a new server name in there, and you got to go and change 600 or so spreadsheets, it's not a fun time in there. So that's why they call them spread marts. And then what happens in the next stage is the data marts, where these companies go, okay, this spread mart's not working, we'll create a data mart on our own. And a lot of times they're isolated from all the departments. So somebody in accounting or finance or sales may go, we're going to create our own sales data mart because we want to build a cube off of it. And we do that without any IT involvement or very little, and we create our own data mart. Well, all the different departments are doing that, so you have all these data marts all over the place. So it's the same problem you have with spread marts. Now you have data marts all over the place. So then and most companies are actually in between, I would say, infant and child that I've been to. So once we get past the child stage is when they just look at the problem of having so many data marts, and they say, we're going to create an enterprise data warehouse. Much better solution, because with the data marts, you can't really go cross-departmental reporting. Everybody's isolated. So somebody realized that's a problem. They create a data warehouse where they put in all the various sources, and the data marts are all within your data warehouse. So that is for most good enough. But what happens is you may have an enterprise data warehouse, and then your company buys or purchases another company, and they have their own data warehouse. And now you may have multiple enterprise data warehouses in there. And then you need to consolidate, because it's almost like taking a step back. You need to consolidate all your data warehouses into one enterprise data warehouse. And I see this happen a lot with companies who do a lot of acquisitions. They have multiple data warehouses all over the place. And then the next one, which is extremely rare at the sage stage, is when they have a nice enterprise data warehouse and you want to share that data warehouse with outside companies, maybe a supplier, where you want to give them a web service that says, hey, you're my supplier, call this web service and you can get back our inventory levels, and if you see them low, then you can reorder something. Or you can give them a nice reporting tool that can go on the web and they can slice and dice and see how their performance is, and how they compare to other customers or vendors in there. So that's with the sage stage. And I would even add probably one more where I'd talk about data mining and predictive analytics, where you're, instead of just looking at where you've been with what you see on here, predictive analytics will tell you where you're going and kind of predict and estimate where you're going with your data like that. That's a whole other topic in there. I didn't put it in there because I don't know what I would put above sage. King, queen, wizard, I don't know. So what is a data warehouse and why to use one? And I like to stress that this is for OLT. This is not for OLTP systems. A lot of these things are not going to apply if you're talking about a transactional type system in here. So the first thing is it reduces stress on the production system. Many times when I was a DBA and I go to a company and there's problems with the source system, the users are using an ERP system. They're finding that it's slow, and who gets to call the DBA, right? And it's always the DBA's fault for any production problems out there. So you go in there and you run your query analyzer and you determine that there's somebody with running some query that's just taking down the whole system. It's high CPU, saturating the bandwidth, and it's some user running a report, and you call the user and like, what's going on? And they're like, well, I'm running this Excel report. I don't know anything about it. It's been around for 7 years, and I've been passed along. And so you realize the problem is that you have transactional users and you have reporting users on the same system, and that doesn't work well. So by creating a data warehouse, you're offloading all those reporting requests to another server and preventing those transactional people from complaining and making your life a lot easier. So you'll optimize that data warehouse for read access. As DBAs, we know we just can't start sticking indexes on tables in a transactional system because you're gonna affect the writes. And so when you go to a data warehouse, you're not concerned about the writes, and you can add as many indexes usually as you want, and you can tune it for reporting and not worry about the transactional side of it. You can also integrate many sources of data, as opposed to clients who will have an ERP system and they'll try to shove every type of data source in there. I want budgeting, I want operational, I want financial data, and they'll try to find some way of finagling it all into the one source system in there. Better solution, create a data warehouse and make that your integration point. You want to keep historical records in there. The problem with a lot of clients I've been to is when they, at the end of the month, they go and create a bunch of reports and they dump them all into like a file share or SharePoint. And they use that to go back in history and look at how these reports were in the past. And you wind up having a big dumping ground of all these monthly reports. Because the problem is, they can't go back and view reports because of issues like they may do customers by state, and maybe those customers have since moved to a different state, and if they run the report now for prior month, it wouldn't be accurate. Well, data warehousing takes care of all that. You can track the history of it all with what they call type 2 dimensions and not have to worry about running those reports. So you don't have to save all these bounds and bounds of hard copy or reports on SharePoint site. It also allows you to restructure and rename tables and fields. So if you're familiar with ERP systems, you'll notice that they don't do the best job of making their tables descriptive. J.D. Edwards is one in particular. You have these tables, T1107, T1109, and the idea is you want to create a data warehouse that you can give to the users and say, you create the reports. Don't have IT involvement in there. Well, to do that, they have to understand the tables in the data warehouse. So as you bring those tables over, you can rename them to something more understandable so the users can have a much better chance of creating their own reports. Because there's usually always some guy, if you don't do this, he's the go-to guy. He understands all these tables and how they join, and he's the only guy that can create those joins to do what the users want. You want to avoid that situation. You can protect against source system upgrades. So one of the cool things is when you build a data warehouse, if you write the ELT code or ETL code to move it from your source system into a data warehouse, and then you generate reports off that data warehouse, if that source system changes, upgrades and such, you don't have to worry that it's going to mess up all your reports that are hitting that. You just rewrite your ETL and keep those table and field names the same, and so your changes are in the ETL and not affecting all these users that are hitting those reports. Because if you create reports off the source system and then they do an upgrade, you may find them all breaking. It allows you in a data warehouse to use master data management. That's a whole other topic in itself, but in essence, it's a way to model data. So you may have multiple ERP systems, and they could all have customer tables, but they all have different types of fields in there. So you need to create a model, say this will be the customer table going forward that everybody's going to use. You can do that manually, or you can use an MDM solution to do that for you. In addition, it'll do things like cleaning up duplicate customers in there. If you merge ERP systems, you're always going to have problems with duplicate customers. They have the tools in there to clean that up for you automatically, as well as hierarchies. So you may want to report of customers, and you want to have a hierarchy of, I want to see customers by country and state and city, and then the customer. And you can build those hierarchies in an MDM solution instead of doing them on your own. So no IT involvement. Unless you really like doing SSRS reports and creating views and queries, better give the data warehouse to the users, say leave me alone, you go and build your own stuff. You know the data better than me. We don't have this back and forth of you create a report, they don't like it, that's not what I meant. They go back and you have to make changes to it. Real pain. And then improves data quality. So the thing I always see at every client is major problem with data quality. They'll go and first thing I'll say is, how clean is your data? I mean, how many problems are we going to see? Some clients will go, our data's all clean. There's no problems with that. And I'll pull out my wallet and I'll put $100 in there and I'll say, I bet you $100 I'm going to find a bunch of data quality problems. I've never lost that bet. Because as you dig into that, you start seeing problems and you go, well, what about this problem? Oh yeah, you know what? We had a bug for 2 weeks and all this data got in there and that was bad. Or I'll look and I'll say, why am I seeing dates that are in the year 5 or 5,000? You know, I guess they didn't know it. They had no idea that users were required to enter dates, and so they would just enter anything because they didn't know the date, right? So you can see those problems, and you go and you can correct the data entry screens to prevent that. But you still have the problem that all this data got in there already that you have to clean up. Always, I'll stress this, always spend a lot of time, or always allow for a lot of time cleaning data when you're building a data warehouse. You're going to find tons of it. I've seen some crazy stuff that have evolved from these data source systems, especially if they've been around for years. And you have one version of the truth. A lot of times you'll have all these different data silos over there. Well, which one should we use when we want to have the true understanding of our business out there? And everybody's got something different out there. The story I like to tell is I went to one client a major oil and gas company who I was tasked with creating a data warehouse. And inside a data warehouse, you not only have data, but you can also have calculations in there that you're going to standardize throughout the company. And I couldn't get one of the, or a number of these departments to balance, to validate the data, the reports we created in the data warehouse with the reports in production. And when I went and tried to figure it out, I spent a week and I just couldn't get them to balance. So then I went to one of the departments and looked at their formula and found out it was different than what I was using. And I figured, okay, well, probably over the years, it got changed, the formula, and they forgot to change it in one spot. But then I realized it was very common to have a different formula for this one calculation. And what I found out is each department, the president's bonus was based on how well that department did. So this financial calculation has some creative accounts that they took out or added in to make sure that number was better than it really should be. And it was scary because they were reporting that to Wall Street. So I went and fixed it and standardized that across all departments. Man, some people really hated me. So that's another whole story. But in the end, we did the right thing. We created that one area that was common among all of that. So you'll see that happen quite frequently when you go and standardize it all. And it could lead to a lot of arguments over what the right calculation it is, but you got to have those arguments if you're going to create one version of the truth. And in the end, it's easier to create a business intelligence solution on top of it. Whenever you create a data warehouse, that's the hardest part. If you look at any BI or data warehouse project, the most time you're going to spend, 75% at least, is going to be building that data warehouse. After that, it's pretty easy. But it's that data warehouse that's going to have the majority of the time for the ETL, the data quality, the master data management, all that is going to take a lot of time. So, any questions on that? I'm such an awesome speaker. Everybody understands this completely well. Right? No, so feel free to jump out if you have a question. Thank you. This is not about Data Vault, is it? Okay, good. All right.
When you start small and you keep on adding to your data warehouse, I'm guessing you don't create the same right from scratch.
Great segue. Every time I do a presentation, I like to have a guy who asks a question where an upcoming slide is going to answer it. So you're Mr. Segue. So I expect you to ask a couple other questions that are going to lead me into it. So we'll get into that in a minute. So this is what you have if you don't have a data warehouse. All these systems are wanting to pull data from the various source systems there. And I've seen this happen before. In particular, you'll have all these link servers where they're pointing everywhere. And that's not the most efficient use of creating reports. So it becomes a big jumbled mess. And if you go and you create a data warehouse enterprise-wide, obviously you're making it much easier for all those different departments to generate reports. And I always like to say the two of the biggest purposes of data warehouse is you're saving time building reports instead of having to figure all this out. I have a very easy solution to build my report, and I may be saving hours and hours every week. I've seen some clients where they had a report that would take 40 man-hours a whole week to build that we had in literally seconds. So those people can spend their time analyzing the data and not creating it and add much more business value to the company. And also allows you to slice and dice in ways you cannot do before. Once you present this data and they have all this free time to analyze it, you're going to see light bulbs pop up in their heads. They're going to go, oh my God, I never realized this data was available, and I'm going to slice it and dice it. And those business decisions, the people who make the business decisions are going to have the ability to find problems and correct them that they never would have before, or have more insights into their data. Another example is when I was at a client and we were looking at the production or the sales of stores over months, and they noticed in one area for a particular a month of the year, the sales were down. And normally that may take them a lot of work and effort to figure out why were the sales down in that store, and the manager came to me and said, you know what, it could be something weather related. Could you import weather information into the data warehouse and put that side by side, and we can see if that was indeed the reason? Sure enough, I got a source of weather, and I put it in there, and he saw it. And he said, oh, yeah, this was caused by hurricanes during that time, so I don't need to worry about it. So things like that happen. You'll see these users, you can actually see the light bulbs go off in there, and they want more and more. So great thing about data warehouse, where you can look at it in a negative light, is you'll never be done with it. Once you put the data warehouse out there and you start giving them insights into the data, they're going to start bombarding you with additional requests. So that little BI project that could be a 6-week or 2-month thing suddenly will be many, many months. Sir? Another good segue question. So, yeah, let me get into that. I think this will answer the next slide coming up. Boom, segue. So you go to your boss, you explain all those things, and he's like, oh my God, this is perfect. You could, hell, go ahead and copy the slide and give it to him and say you created it. That's fine. And he's going to be very impressed. But then he's going to go, okay, go and build it. And you're going to go, okay, we need to get hardware involved in this, like that. So a lot of clients I'm at, that process there can take months, because you got to get a DBA and a network guy and a hardware guy together, and you got to call HP or Dell, and you got to talk about what you're going to need, and you don't really know, and then you got meeting after meeting after meeting. Finally, you decide to buy a system, and the hardware is like way too much, way more than you really needed, or worse, it's not enough, and you get into your data warehouse, and suddenly you're having performance issues. Well, Microsoft came up with what's called the Fast Track Data Warehouse, which is a reference configuration optimized for data warehouses. So they kind of went through this pain when they were building a parallel data warehouse and came up with this 50-page document that you can download that tells you the type of hardware you should get, how it should be configured, operating system, SQL Server, BIOS, everything's in there on the proper way to configure a server to get the most out of it. So you can go and call Dell and say, I want a Fast Track Data Warehouse. And they will say, okay, these are the parts you want to get, and then you go and you put it all together, and then you can continue to follow the document to see the settings you need, and you're going to have a machine that's going to perform to the max capacity. And it's usually hardware, it's usually disk I/O related. The bandwidth is always usually the problem. The CPU is rarely getting taxed. It's usually, CPU can't get the data enough, so these are designed to funnel all that data into the CPU quicker than you would if you just kind of guessed. Going a step further, you have an appliance. So a number of the vendors have a pre-built appliance that's based on the Fast Track Data Warehouse architecture. So instead of you having to put it together and install the OS and the SQL Server and tune that, you just call them up and say, I want your appliance, and they'll send it to you. You plug it in, a wizard fires up, and within a couple steps, you have a data warehouse application or appliance for you. And if you go down, if you look at the specifications there, they'll talk about all these different configuration systems related to software, the database, and the hardware. So in the end, I like to say this takes the guesswork out of building a server. It reduces your risk. It makes it much more likely you're going to be successful with the hardware that you purchase. And if you go downstairs and you talk to Dell, which I did before I came up here, you'll see they have two appliances, 1000 and 2000, and they're about to come out with a new one in a couple months that has is a lot more powerful. But all these vendors have these data warehouse appliances ready to go. So you're not spending months to get your data warehouse project started, which is what I see. We go there, we want ready to go, and we're waiting for hardware. And I've seen companies take 6 months to get the right hardware in. And it may not even be the right hardware that they needed. Sir? So we have a Cisco guy in the room.
My server team is Cisco, but we went to the UCS presentation.
Yeah, so, right. So, well, I guess I did have space here, but that's just a few of the ones that I pulled out. And they all pay me to put that on there, so Cisco's we got to talk. And then there's also the parallel data warehouse. So how many people here, show of hands, know what the PDW is? I didn't say put them down. I didn't count. 1, 2, 3, no. So I would say there's only a handful. So quickly, the parallel data warehouse, the problem you have with single processor CMP systems is you can scale them up, but at a certain point you may reach a limit where extra hardware, I can't get any more hardware. I'm at the max capacity. So you start scaling it out, and that's what MPP is with parallel data warehouses. It allows you to purchase as many servers as you want, and you distribute the data over all these different servers, and then you have a control node that queries will be sent to, and it will go out behind the scenes and query all those various servers and bring the data back to you. So we've had projects I've been on that have terabytes of data where you'd run a query with regular SQL Server and it may take 3 hours, and it literally will take sub-second response. So I hit the return and I see the result and I think I made a mistake, but I realize, no, there's the results in there. That's how quick that is. And that, it's been around for a couple of years. They have version 2 now. That's 2012. They've given a lot of demos on that here. But it's a great solution if you get to the point where you have a ton of data and you need to spread out. Sir? I'm getting some good... Yeah, I'm getting some good questions here. And I don't talk about the cloud here, but the only one out there right now is Redshift by Amazon. They have a MPP solution out there that you can go and purchase for large data warehouses. Of course, you can always fire up Azure virtual machine and use a data warehouse on there, but there's limitations. I think it's like 250 gig is the most you can have on there, so you have to shard it out by spreading it out among different servers. Not an ideal solution. Microsoft is working on it, I should say. But, and then there's also Hadoop. So if you look at PDW behind the scenes, it's kind of like Hadoop, the way it distributes the queries out. So that's another solution, but those are other sessions for that. So it's a performance issue. If you put in, it's that old debate of the virtual machine, is it performance-wise is as good as having the bare metal? And some would argue it's just as good. A lot of it is your disk subsystem. What is connected to a virtual machine? If you're connected to a SAN, generally the performance is going to suffer. And the appliances all use direct attached storage for that to avoid that SAN problem like that. What's that? We'll take that offline, so there's more to that. We're getting into the hardware discussion of it. So a data warehouse and a data mart, there's always confusion at clients of what's the difference between the two. And people use them interchangeably. And I like to briefly talk about that a data warehouse is where you put everything. All your different subject areas, finance, marketing, sales, etc., are going to be in a data warehouse. A data mart is will be a subset of a data warehouse. So you may create a large data warehouse, enterprise level, and then you may have data marts that are copies of that data in another location. And if you think about it, if you created data marts for all the subject areas in the data warehouse, then your data marts are kind of like the logical combination is considered a data warehouse. So data warehouse, all the subjects, data marts, individual subjects. Any questions before I get onto the really heavy topic? So I put this picture up here because, well, how many people here think they have a good idea what the Kimball methodology is? More than half. How many think they have a pretty good idea of what the Inmon methodology is? Only a couple, right? Anybody here would say their methodology is Inmon in their data warehouse architecture that they have at work? Ooh, nobody. Well, I'm going to clarify that because a lot of people are using Inmon and they don't realize it. And the reason I put the fight on there is because do this as an experiment. Go to LinkedIn, to discussion groups, and say, can somebody tell me what's better, Inmon or Kimball? And you briefly would turn into a flame war where people start throwing blows at each other, and it quickly degenerates into a shouting match. And if you don't believe me, just go there, and they're out there. I've seen plenty of them. where people go crazy. Are very passionate about it. And I don't know why, because as I'll explain, they actually can work together well. They're not, this animosity on there is misguided, I think. And I want people to understand that they can be very compatible and work together. And you should all have a group hug instead of fighting. We'll do that afterwards if you want. So the Kimball and Inmon myth. So when I did this a couple years ago, there was actually some myths that I believed. I didn't understand it well enough as I researched this, and I had some misguided beliefs. And the first one being that Kimball is a bottom-up approach. So we think of it as, I'm going to have a quick win. I'm going to go build this data mart for finance, and I'm not going to think about anything else. And then once that solution, users are happy with it, I may go build a data mart for sales, and then move on to operations and such. And so I'm building all these data marts, and the combination of those is a data warehouse. But I don't spend a lot of time designing things. Well, that's actually a big myth. If you read the Kimball books, he talks about the bus matrix, which is where you go and you identify all the data sources and all the dimensions that you're going to use, and you put them on a nice bus matrix. So you have a good idea of the direction you're going. And that bus matrix, you may have conformed dimensions where you'll need to know if I have a customer as a dimension, I can use that to link up operational and sales data. So you want to find those dimensions you can spread across those various source systems to link them together. So that can take a lot of time to create that bus matrix. There may be some master data management involved in that solution too, because you may be bringing some systems together that have the same data like customers. Then you'll focus in on one particular area that maybe has a high priority and get a quick win, and you'll go on from there. But you have a good design of the whole thing. And I've actually talked to Kimball about this, and he says, I hate when they call us a bottom-up approach, because in his argument, they spend more time than the Inmon methodology in designing the system. The other myth is that Inmon requires a ton of upfront design, kind of the opposite, where people think with Inmon, I'm going to spend 6 months to a year designing a system before I even let any user see it. Well, that is very untrue, and I put these pages in there because people argue with me about it, but some of these are 10 years old where he talks about, he doesn't want to do the big bang approach. And I also, Inmon was nice enough to reply to a lot of my emails about this, and that's where I saw him and Kimball I won't get into it, but he told me, he's like, look, this is not like I said, you're going to build a city, so you're going to go design the whole city, you're going to design all the towns and all the water systems, and you're going to spend years and years to do that, and then you're going to go and I'm going to build the whole city, and I'm not going to let anybody in until it's all done. He says, no. Design the city, spend some time understanding the overall architecture for it, and then you pick out towns, and you go from there. So it's very much like the Kimball method. Is you need to have that upfront design, but you're not going to spend months and months before you see any solutions. And that's where the iterative approach comes in. The agile approach comes in to building these solutions out. All of them should do that, because you'll never have a successful BI project if you take months before the users see anything. Every time I go into a meeting after a couple weeks, they're banging the table, we want to see something, we want to see something. So you got to have results quickly, or you're going to lose the business users. Especially if early on you get them excited about it, and then you take months to deliver something, you're going to lose that momentum there. The other myth is that star schemas are not allowed in the Inmon model. How many people here know what a star schema model is? Oh, good. I don't have to go and explain that. So people think, well, if I'm using Inmon, I'm not going to be able to do that. Well, that's not true. He is for building the enterprise data warehouse, but then having data marts that are in star schema format that are great for end user access and that. So he is very much for that. And then the other myth, very few companies use the Inmon method. There was a study done about 5 years ago that showed there's actually more companies that are using the Inmon method than Kimball. And that's because they're using enterprise data warehouse, which is not in the Kimball method. So if you're using enterprise data warehouse here, you are more towards the Inmon method than you are the Kimball method. Right? So that, and there's no one, there's always so many variations, and you've got to categorize them into one or the other, but most of them categorized into the Inmon method. And finally, that they're incompatible. The reality is, as we'll go over, is they can actually work together and be compatible and provide you with a better solution than just trying to do one on their own. And a lot of it comes down to the relational model, heavily used in the Inmon method, and the dimensional in the Kimball. Neither of these guys invented these models, but their books heavily rely on one or the other. So we got the relational model. It's an ER model. You got normalization, third normal form, hopefully. You got many tables out there. A customer table may be comprised of 10 different tables, and you use joins to create them all. You may track the history of changes, like a person moving from one state to the other. And you'll use natural keys. That's really good for indirect end-user access, meaning we don't want users to hit this relational model. We're going to build a data mart, and they're going to use a data mart for access. While the dimensional modeling approach is using facts and dimensions as our schema, of which most of you know, we will have less tables, but we have duplicate data because we're denormalizing it. And that makes it easier for users to understand, but strange for IT people. And I had this problem, and I'll jump to the next slide, is here is a relational model, and for product, we have 10 tables that have product information and one fact table that contains the sales. If you look at any typical source system, especially a third-party company has built, you'll see a lot of this going on. This could be hundreds and hundreds, sometimes thousands of tables in here. Dimensional model takes all these, combines them all, and puts them into one product table. Now, many years ago when I first heard of the dimensional model and the star schema, and I saw that, my reaction was, as a DBA for many years and using a relational model for many years, I was like, are you high? Why? Product color description? I'm going to repeat that? That's insane. But the more I got into it, the more I realized, if I'm a business user, I don't want to look at this and figure it all out. I just want to have something like that. And when you understand the purpose of a data warehouse or a data mart is to give the users the data and have them create their own reports, you don't want them to have to try to figure this out. You want them to be able to do this. And if we have other dimensions, a date, a store, a promotion key, that's where the star schema comes into place. So jumping back, and the other ones is you can use slowly changing dimensions. You got type 1 and type 2 to track the history of a person moving from state to state. You got surrogate keys, which are mainly identity column, which we may talk with later. That's a way to put the data together from various different source systems into one table, because your natural key for this ERP system may be an integer number from 1 to 1,000, but then you may have another ERP system that's using the same thing. Well, how are you going to differentiate those two surrogate keys? And you also need surrogate keys if you are tracking the history, because you'll duplicate the rows in there. And then it's great for direct user access of data. Like I said, it's much easier for a user to be provided this than this mess. Oops. So, any questions on that? So think of the Kimball methodology as it's called the logical data warehouse or the bus architecture, made up of many subject areas, all different data marts that are all logically linked together to form a data warehouse. It's more business driven in that usually when you're creating these subject areas, you'll have a lot of interaction with the business user to define it. Like if you look at the Kimball methodology, he has spreadsheets where you go and you work with the user, and sometimes you give it right to the user and say, you design this star schema. You also have decentralized data marts, meaning they're not dependent on another source to build them. They're all independent out there because you have no enterprise data warehouse that they're coming from. A point of confusion is the data marts, that doesn't mean they have to be a separate physical data store. Where in Inmon method they are, in this methodology, they could actually be just schemas, different schemas on the same database, right? They don't have to be separated out in data warehouses on there. And we'll talk more about that in a minute. And because they're star schemas, they're optimized for reporting. So they're a great solution to give to a business user to generate their own reports. They're integrated versus conformed dimensions I talked about before, so that provides that consistency across all the different data marts or the sources. And then it's two-tier, meaning that you'll have all your data in a data mart, so there's no duplicating it. You'll have a data mart and then maybe a cube built off of it, so there's less ETL. Where in the Inmon methodology, he has what's called a corporate information factory, where you have this enterprise data warehouse. It's less users' involvement because it's very much based on the source system, so you won't be asking the users a lot of questions on how to design it. It's centralized, and it's off limits to users. In his methodology, the users should not be touching this enterprise data warehouse. If they need the data, put it in the data mart. And then later, once you create this enterprise data warehouse, you'll create those dependent data marts, and those will be physically different subsets of the EDW. And you can use them for multiple purposes, because you may actually want a data mart that's in third normal form, because maybe you're going to extract it and send the file off to somebody. So star schemas sometimes are not always the best solution for various reasons. It's all integrated because you'll have a giant ER diagram that shows you how everything's interrelated. One negative is now it's called three-tier, because you'll have copies of the data in a data warehouse and a data mart, so you have duplication of data. But this space is pretty cheap nowadays, so I've never seen that as a major problem. There's a little extra maintenance involved in it, so you got to take that into account. So if we look at the traditional Kimball model, we have our data sources. We'll pull this data in, usually via SSIS, into a staging area. So we quickly got this data on a data warehouse server that we're going to use to make it quicker to translate that data into data marts. These will be your star schemas. Again, they could be just schemas within a large data warehouse. And then from there, you can build your multidimensional. I didn't put tabular in here. You can have a tabular model. And what I want to stress is that it's not one shoe fits all. A lot of this is going to depend on your source systems, how many you have, how big they are, because it may be such that I don't need to create a star schema. I have so few tables here, I'll just create a view that will look like the result will be star schema, but I don't need to actually copy the data over. So we're saving a step in here. And the reason why you do the staging is because you want to limit the source contention when you're using the LT in here. You don't want to spend time translating the data over when that'll be taxing the source system. And you also want to do staging because of many clients I go to, they put the data in staging and it gets deleted from the source system, or they want to go back and debug with some problem in this one of the data marts. Well, while it's in staging, you can back it up and go back and look at it later in case there was a problem and you want to debug it. Or auditing reasons, you can put in there how many rows and such were copied over to make sure you're validating the data as it goes all the way through. The Inmon methodology, on the other hand, you'll see the big difference is we have this corporate information factory, this enterprise data warehouse, where we're pulling the data again, but before we get into the data marts, we are storing it in an EDW. From these data marts, which will be normalized, we can then build our cubes. I do have tabular in here because tabular can go against a normalized data mart. It doesn't have to go against a star schema. So that can provide some time savings for you. And then we're off running the reports against the cubes. So a lot of times people, when they see this, they go, well, do I really need an enterprise data warehouse? Can I get away without having that? Well, yes, but some things to think about. The benefits that I'll get you of having an enterprise data warehouse is a single version of truth. Because a lot of times I'll see where people start creating data marts, and if they don't physically put them on the same data warehouse, database, you start losing what the source of the truth, the single source of the truth is, and you'll have multiple ones out there, and it gets to be a real pain. Question? Yeah, so, yeah, great question. So this dimensionalized views is not usually the recommended way of doing it because this could take a lot of time to put together. And it's better, always better to build a cube off a star schema which is why we have the hybrid method, which I'll talk in a second. So you are now the new Mr. Segway, because I'm going to talk about that in a minute. Oh, sorry. He was asking if, the question was, is this a good idea to have a dimensionalized view, to build cubes off of a star schema, or off a normalized view instead of a star schema? Right, and the answer is, you want to build cubes off a star schema. My bad, I was supposed to repeat the question. They banged that out in my head and I forgot. So the reason to add a data warehouse, a single version of truth, it may make building dimensions easier. So I look at it this way. If there have been many projects where I try to go from the source system right into a star schema, and you can write some really complex ETL views to do that conversion in there. Think of it as breaking up a really complex problem into a couple of smaller steps. One of those smaller steps being, I'm going to lightly denormalize the tables as I move it from the source system into the EDW. So going from there to the star schema is a much easier operation than going directly from the source systems in there. So that's one very big reason why EDW can give you a lot of benefit. It also allows you a lot of consistency when you want to create data marts. Now I have everything in one place. I can standardize on rules and dimensions, and I can build my data marts off that much easier than trying to figure out all these different source systems I got to go from. Everything is already in there, and it's a lot easier to build it from that point than going back to the original source systems. And it's less ETL and reconciliation. So you got to validate the data as you move it over. If you have all these different data marts from all these different sources, and they may be, some of those sources, those data marts may be refreshed daily, some weekly, some monthly. You have one source system. What I see is all of a sudden this source system is now being moved, the ETL, through all these different data marts. And you start losing track of what the source of the single source of truth is. You start losing track of validating the data, and it makes it much more difficult to try to validate the data if you have all these different data marts in there. So it just provides one cohesive area to have all your data and know that that's where it's coming from. It's one place to control the data, so you don't have all this additional duplication and effort of data. Because you'll see people create a data mart, and then somebody will say, "I need to create a data mart with financial data," and it's already out there, but they don't know it's out there because there's no single source that they can go and look through it all. You have nobody who's kind of like the keys to the kingdom that will be in charge of the enterprise data warehouse, and it's a lot easier for them to funnel requests to say, I need financial data, and they'll go, yeah, it's right in the enterprise data warehouse, it's right there. Because you'll start seeing all these people go off and create their own data marts, and it becomes a big mess. Yes?
What is the reasoning for going from a data warehouse to data mart versus
So,
go directly from the data warehouse to report?
so the question is, if we look back here, why would you generate reports that, why don't just go right from here, right? Well, first of all, Kimball says no, or Inmon says no, don't do that. We don't want to have users in here. Now, there's valid reasons for that, because you could be updating this while they're generating reports. You could have this in a structure that is not what you want to present to users. Because in the end, what you want to do is give them a star schema that makes it much easier to generate reports from that. Now, you could argue, and which I'll show in a minute, that this could be a star schema as a hybrid method. So you and I are the Mrs. Segway. Yeah. And so the reason not to is if you only have a few sources of data, you may not want to go through all this trouble. Especially if you're doing a POC. I wouldn't recommend going and building an enterprise data warehouse for a POC. Or you're just going to go and you're going to do something that only one group's going to use. But the caveat is, how many times have I heard, oh, this is going to be a one-time shot thing, and then all of a sudden that starts blowing up to adding on to it. And we didn't spend enough time up front, and now a year down the road, 2 years down the road, we got this one big jumbled mess of a data warehouse because we didn't do the upfront design work that we needed. We didn't create the enterprise data warehouse, and you wind up going and redoing everything. And you bring in a consulting company to help you out, and it's just a lot of time and effort wasted that if you had done it right from the beginning. So which model to use? They're not that different. Hopefully I explained enough where you understand. They've become very similar over the years. When they first came out with these 20-odd years ago, they had a lot more differences in there. But over the years, they've kind of come together after much bickering and yelling back and forth. And you'll read Inmon and he says, look, they're copying what I did. And Kimball will say, look, they're copying what I did. But in the end, they've become quite similar. Because really the only difference is Inmon creates a normalized data warehouse before creating a dimensional data mart, and Kimball kind of skips the normalized data warehouse. So you just got to tweak each model, and they're pretty close. If I add the normalized DDW to Kimball, then I have the Inmon method. And if I add dimensionally structured data marts to Inmon, I have Kimball methodology in a way, right? So we'll see a picture of that. So bottom line is understand both approaches and pick best parts for your situation. You don't need to say, I'm going to definitely do this method, I'm going to definitely do this method. Everybody's going to have a different solution in here if they built a large enterprise data warehouse. There's going to be certain spots where you're going to decide, I don't need a start schema, or I don't need to create an enterprise data warehouse in this particular situation. It's going to vary widely. And I always like to stress, but no solution is going to be effective unless the person running it has those soft skills to pull it together. Many projects I've been on, you're going to find an environment where you're going out and asking for data at different departments. People are sometimes real reluctant to give up that data. They want to control the data. They don't want anybody else seeing it. This data warehouse scares them to death. And if you don't have the personality skills to make them understand what you're trying to do, to make them sit in a room and talk about key performance indicators you're going to want to create across the company, you're going to lose them and the project's going to fail. And I have a whole other presentation on best practice for a BI solution. And the biggest part of that is the soft skills you got to have. I know as DBAs we're kind of introverts, and I was that way many years ago too. But once I got into BI, I found I'm now interacting with a lot of different departments. I'm a lot of times interacting with the CFO, the CEO, because they want KPIs out of the data warehouse. So I kind of got out of my shell and realized the projects that I were on that were not successful is when the key leader in there didn't have those soft skills. So in the end, what we can wind up is a hybrid model. And you can see, I like to stress, we're going to mirror this data. It's a copy of the data because we want to avoid, as much as possible, pulling ETL over from our source system. So if you have an environment where you can set up, anyways, you can copy the tables, you can back up and restore them, you could use transaction logging, you can use availability groups. Try to do that, and so you're putting less stress on the OLTP systems when you're creating these staging areas. Once we create these staging areas, you'll see this looks like Inmon right here, but then when we get to here, we're using star schemas. So that's the difference, and then from there we can build our cubes and do reporting data. Maybe we don't even need cubes. If you went to session before with Jimmy May, he talked about column store indexes, which I was glad to hear are actually, in some cases, he's seen faster than cubes. So maybe this star schema, I put a column store index on there, and I can do reporting right off of that and not even use a cube. Save all that processing time. And I like to mention that the data, this star schema right here, this data warehouse, this could be all in one database. And that segue before is I can actually replace this with all my tables in a star schema format and build off data marts here that are star schema. So that's another solution we have, is maybe my data is not that complex where I don't need to have this normalized form in here before I get to the star schema. It's that all depends on your situation. Sir? Yeah, so that's the biggest reason why I usually recommend clients have this. I want everything in here. I don't want to have these data marts all over the place. And they may all start out being in the same data warehouse under schemas, but eventually something happens and you need more space and you need another server because this one's not performing enough, and you go and you create another data warehouse over there, and it just becomes all convoluted mess in there. And that's why I always like to say I can always go back here and know where all my data is. And I can fill this up with data I may not even need yet. Maybe down the road I'll need some start schemas, but I'll put it all in here for now. And later we have it sitting there in case we want to generate a start schema from it. Sir? Oh, you're a little early on the segue, but I get to that in a slide up there. So pay attention here. We got to, yes. corporate information factory.
Right. Because after we get the data
Um,
I want to hook up with Stella. I understand my data.
no, never users never say that. Yeah. The worst part is when the IT says they know their data better than the users. Don't ever say that. This thing will come flying doink like that and hit your head. And you start right off the bat. I've seen managers do that, and right off the bat they start with the contention. And instead of being, hey, we're all in this together to build something, it becomes you against me like that. So yes, I've seen cases where users want to just go in here. Again, it depends. Maybe if I don't have a lot of data in here, and they can go against it. But the problem is usually this will lead to performance issues. They can't go in here for two reasons. One, there's so much data. To join it all together, it's too time consuming. And two is it's too hard for them to understand the data in a third normal form. They have to join all these different tables together. You can make the argument, well, you know what, they got this column store indexes, James, which you just talked about, and I can do that there. It may be the right solution. And part of a lot of architectures that I develop for clients, we're doing this right now, is I have a lot of technologies to prove out as we go in there. Here's the methodology I want to use. We're gonna skip this and just go with columns or indexes in there, but we got to test it out with the data that they have to see if that's going to work. And if not, we'll have to go to Plan B in there. Yes, sir.
What kind of criteria do you use to decide what data marks you're going to produce from these data?
So the question is the criteria for the data marks. With the Kimball methodology, really you can do the same thing with Inmon methodologies. You're going to build a bus matrix, and you're going to look at all your data sources and all your conform dimensions. And then you're going to decide, and you're going to interview all the different various groups to figure out what's there. And you're going to build it out, and then you're going to go, what's something that's a high priority that we can do quickly, and usually pick that one. That's kind of how it goes. Or it may be a corporate directive saying you're going to do that no matter what. Yes, sir.
You know, building a corporate data warehouse is lots of different data sources, lots of different values, but you said something about how to develop something fairly quickly, get it out the door, sort of add growth and add on to that. How do you do that in an environment that has a whole bunch of different data sources and you really want to get something out that's useful but not take years to build it?
Yeah, so if you have a lot of data sources and the users want something quickly, how do you get that out the door? And there's that balance is how much upfront design I want to do and what are they pressing me for. As a consultant, I go in there and I'll tell them, look, I need to spend 6 weeks understanding all your data sources, and then I'll have something in a couple weeks after that. And they go, no, we want something by this date. So you got to make a compromise. So no matter what, I try to get an overall landscape of everything, but then I may take shortcuts in the areas I'm going to dig a little more deeper into. It's just a call of what the pressure is from up above, and usually it's financial data. So, okay, I know I can get the financial data from one or two different sources, and I'll give them something that they can be excited about, and so it's not a bad idea. I can pump that out. But usually it involves a POC where you say, I'll give you something, I'll show you what you can do, but we're going to re-architect that, but hey, you got something now, and now you see the power of a data warehouse, because it's kind of you want to get users excited, you want to get buy-in, you want to get a champion of your cause, and the best way to do that is through a 2 or 3 week POC where you can show them. Because many clients I've gone to, they've never heard of Performance Point. And you show them what Performance Point can do, and they're like, oh my God, I didn't know we can do this. Because it goes into that, it's really hard to, users don't know what they don't know. So if you ask them what you want, and they haven't seen anything, they'll just go, oh, I want reports, and they will tell you exactly the reports they have now out of the source systems. And you'll go, well, there's this other way of doing it. Let me show you. And they'll go, oh my God, I didn't know that. And then your requirements completely change in there. So the POC flushes that out. So you do an iterative approach with one area, and then you set the stage for prior solutions in there. It's a whole agile methodology that you design a framework, you design a process, and you repeat that over and over again with different source systems.
So you're sort of suggesting maybe doing a subject area at a time and then eventually over time you'll build that corporate data warehouse.
Right. So, well, yes. So, again, maybe I didn't stress enough. In the Inmon methodology, you're not building all the data warehouse, all the data sources at once. You design them all, or have some good overview of them, and you'll just pick one area. You never want to spend a lot of time building, because you'll lose the business users in there. So pick one or two areas and go for that, no matter what methodology you're using. We can talk offline more about that too. So the Kimball methodology, when I want to talk about the point of confusion is people will say, oh, we do the Kimball methodology, we're designing our data warehouses that way. Well, the Kimball methodology is more than just building data warehouses. It's also the whole life cycle involved. So if you're not familiar with the whole life cycle, go and buy this book, Microsoft Data Warehouse Toolkit. He explains all this. Right after the show, go out, after you give me a great review, go to Amazon and purchase this book. And maybe I'll give you a free one if you have a good review. No. And with the Inmon methodology, it's more about the data warehouse, not so much how it's used. So you can be a Kimballite, you can have the business development lifecycle. I do that in all my projects. But when it comes down to the physical design, I may vary a bit from the Kimball methodology on that. Any questions on that? As time permits, I'll hang around here. We got 10 minutes to go. I'll hang around here as much as possible, answer questions, and you can feel free to email me, which we'll get to at the end. So quickly to cover the populating data warehouse, because this is another thing where I see people make a lot of mistakes, is we understand the data warehouse and how we're going to build it, how we're going to populate it from all these source systems. Are we going to use daily, weekly frequency? You got to understand that, because that's going to guide how you design your ETL to do that. Are we going to do a full extraction? Maybe our data is small enough that we can just do a flush and fill each night. But the chances are you can do that with dimension tables, but you usually run into very large fact tables. Maybe your order history could be millions of rows a day, and you can't flush and fill that every night. So with that, you'll come with an incremental extraction where you only get the data that changed from the last run. Okay, great, let's do that, but how do I know if the data has been changed? Well, hopefully your source system has timestamp. Many ERP systems don't have timestamps. Or they do when you go there and they're all blank. I've seen that many times. What happens if that happens? Well, maybe you can put change data capture on SQL Server on that source system, but you may not have SQL Server, or you may be not allowed to do anything like that on the source system server. So other solutions, you can partition by date. If maybe you do that by day, and then each day you just take what's in that partition. Another way around that, maybe you put a trigger on the table. Each time there's an update, insert, and delete, the trigger will populate an auditing type table, and you can use that. Other solutions are a merge statement. It's a great SQL statement where you can compare the source and the destination and tell it everything that's been changed or updated I want to change, everything that's been inserted I want to insert. It's a great quick solution than creating all these individual SQL statements. But the DBAs, you all know that. And then you can put a column default on there. Maybe the source system will allow you to add a field, and you can populate that field with a timestamp whenever something's inserted or changed. You also got to look at, am I going to be able to have an online extraction where I have the ability to go right to the data source? That would be great in every situation, but a lot of times you don't. They're going to say you don't have any access. We're using, God forbid, Oracle or some other system, and we don't have access to it directly. So what are we going to do? Well, we can replicate that data over, maybe, and get it to us through wherever that source system can do that. Maybe we take a database snapshot if you're using SQL Server. Maybe use availability groups. But it may come down to, if we have online extraction, we can use those methods. If we don't, we'll have to use offline extraction, which means we may have to get flat files, and we have to then create the SSIS packages to handle flat files. And every project I've been on is usually some of that involved. ELT versus extract, transform, and load versus ELT is important because I see a lot of people, as they're pulling data from the source system, they're trying to transform it all. And as I mentioned before, that you can put a lot of stress on the source system if you're doing that. Instead, a lot of times it's better to dump it all into your destination data warehouse and then transform it in there. So instead of having SSIS control all the transformations and kind of do it as a row-by-row approach, you can batch it all over. And on the destination, you were using everything locally there that I can do batch updates to and transformations to, like that. So what happens is your SSIS becomes more of a workflow management solution where it may be calling a bunch of stored procedures to do all that, and you're using your database engine for those transformations, so it's much, much quicker. Yeah, use SSIS if you've got a small data set, and it's nicer to see how everything's working, and it makes it a little easier to develop or make changes to it. Well, that is if you're familiar with SSIS. But if not, if you need performance, that SSIS may become too slow, and I've seen that in many projects where SSIS becomes the big bottleneck because we're trying to do too much within it. Especially if you're using the parallel data warehouse, they don't have the concept of ETL. It's all loading first, and that you have to do it with a large appliance there, and they do it because of performance reasons. How many people here know what surrogate keys are? Just about everybody. So I'm not going to cover that much other than tell you what I said before, is that's a way to combine different data sources together. And the only thing, the additional benefits it gives you is it can do things like have a -1 in the dimension that's for unknown. And if you get a fact table and somebody has a customer that doesn't exist in the dimension table for whatever reason, you can put that you can assign that -1 and put that in an unknown bucket. So when users run a report, they actually see those totals correctly. And it's in an unknown bucket, and they can figure out why, but you're not just throwing that away. And it also improves in performance greatly when you're using surrogate keys because you're using integers. And SSAS cubes. How many people here actually use cubes off their data warehouses? Okay, a lot of people, so that's good. So again, this is changing a lot with the new columns for indexes, but the cubes allow you to, basically you're summarizing the data each night, so you're not having this complicated sum and group by in your SQL clause. Instead, you're just having pull the value out because it's already been summarized for you. So it's for great performance, especially when you're using dashboards, and you don't want some executives spending 5 or 10 seconds going between dashboards and slicing and dicing. You can put hierarchies in there, and you can have advanced time calculations all built in the cube. And then it allows you to easily use Excel, can attach right to it and use pivot tables, and it takes care of your slowly changing dimensions. So this is the segue question I had before, is in the end you may have it look like this. You have your source systems where you're gathering the data into staging tables. You're going to go and clean and master those before you get into where you store everything. When you get through here, you may have DQS or MDM. These are Microsoft solutions to clean and master the data before it gets in the data warehouse. So you're always doing this before you get everything in the data warehouse. You may have an ODS system sitting out there, a whole other subject. But all those will lead into your data warehouse. And from there, as we talked about before, you can generate your data marts and your various cubes. And then the reports will all land on SharePoint. That is the Microsoft Universal Platform now for just about everything. You just create a report, they're going to put it on SharePoint so everybody else can use it. So the tabular model changes things a bit in that you don't have to create a star schema on it. A lot of debate. There was a session before that talked about tabular versus multi-dimensional, but just be aware that this is a solution that could give you some shortcuts to creating a star schema from it. And then lastly, I always like to point out there's a lot of Microsoft tools which are great, but it causes some confusion on which is the best tool to use for which situation. And also causes confusion on what you can use against it. So if I want to use PowerView and I don't have a cube, I'm out of luck. So PowerView, if you get into Performance Point, they all require a cube. So if you decide you're going to get rid of a cube, great, but just realize you're not going to be allowed to use a couple of different products like that. A lot of what I talked about here is in my blog, and I go in more in depth. So you're welcome to visit and find out more information. And I'll open it up. We have 30 seconds for questions. So here's what I'll do is I'll take questions over here for anybody who wants to come up. And I'll be happy to answer for the rest of the day. And as well as you can email me. I mean, I'll answer within a day any questions you have. Just say, I was at your session. I have this follow-up question. I'll be more than happy to answer it. And then, like I said, a lot of the stuff is on my blog where I go into more detail on it. So I thank you all for coming. And come up here with questions.